Now, what this process just did is it did not actually update anything. It got a new listing of the available updates. So it technically updated the database of available packages. So the command that we're going to perform next, which is upgrade, is going to actually install any packages that are newer. And as I stated, as you can see from the screen, I'd already performed that action earlier. So there we are. All right. Sorry about that. So back to our slides. So you saw that you have the encryption options at the beginning. If you were to neglect to encrypt the drive during the installation, it is possible to go back and encrypt it later, but it is very difficult to do so. You can encrypt the home drive, your home directory, much easier after the fact than you can the drive itself. So it's much safer and much easier to go ahead and do that when you're installing the software. So what we're going to be looking at now is the address space layout randomization, and that is in essence, it is the pointer in memory space that a particular process or application is running in. And what a lot of malware and threat actors do is the tools that they use to try and get into your system, it's geared towards trying to actively guess what area of memory that application or data is currently residing in, and that allows them to either exploit the system to perform additional actions or to capture that data. So what we're going to do is we're going to walk through and show how you can check what that setting currently is, and to show you the difference between when it's set and when it's not set. So what we're going to do is we're going to first protect the shared address space. So we're going to add some lines here, which I've already copied onto this system to help having to avoid, and that's because I typoed that. There we go. All right, there we go. So what we're going to do is we're going to add in a line which is going to prevent memory from being, the shared memory from being used by other applications. So what this statement says here is it's saying that it's not going to allow execute permissions, and it's not going to allow to set the user ID, to set the UID. And what that is the UID is how Unix determines your group memberships as well as the individual that you are, and I'll show you that in just a moment. So right now, can you see the shell screen? Is the shell screen large enough? Command line? Can everybody see that okay?
Yes, ma'am.
I think that was a yes. So we're going to use the LDD command, and we're going to pull up the bash, which is a particular shell within any Linux environment. And what we're going to look at is I want you to focus on this top number here. That's the address in memory that particular process is currently using as it ran. And you'll notice that each time we run it, that is a different area in memory. So we know that those settings are actually already configured. But if we wanted to view those settings, we could use what's called the syscontrol. And we're going to look for and view that particular setting. The one that we're most interested in is the randomized virtual address space. If this was set at 0, it would show that it was disabled. So what we're going to do to show the difference is I'm just going to briefly change that configuration parameter. So now you can see that that is currently set to 0 instead of 2. So if we run our command again, you'll see that every time we run that particular program, it uses the same memory address every single time. So we're going to put that back. Some of the additional items that you want to make sure and try to configure not only on your Windows system, but also on any system, operating system, is you also want to harden the passwords and password configuration. So we're going to be setting up some complexity rules. It's kind of difficult to see this on the screen. You'll see it a little bit better when I switch back over to the VM. But just to go over what some of this information means, and there's a second slide that'll go into each of the different parameters. But for example, what this is saying is that you can retry 3 times with a bad password before it locks you out. The minimum length of that password has to be 10. The maximum repeating characters, so you can't have QQQ or repeating numbers or characters in your password. The credits, the U credit, L credit, D credit, and O credit are upper, lower digit, and other, which is basically special characters. What this diff OK parameter does is it's saying that you have to be, when you go to change your password, it has to be at least 3 characters different from your last password, so that you can't change your password and just offset it by 1 digit or 1 character. The GCOS check is what it's doing is it's looking for information in the password file for your username information, just making sure that none of the information that's in that is also in your password. Similarly, for using your username, you're not allowed to use your username to set up your password. So what we're going to do at the moment is we have to install some additional tools in order to set up those particular parameters. So let me just switch back to the virtual screen, to the VM that we're working in. Can everybody see it there?
Yes.
Yep, you can see it.
So I've done these a few times already, but it's much easier to have some of them already handy so you can just cut and paste. So what we're going to do is what we're installing the PAM libraries, and what that does is it's an additional application, if you will, and the which helps to compare the hash word history, because that's one of the things that we're going to be setting up. So what we're going to do is we're going to go ahead and install those, and then once we install those libraries, then we'll be able to make the changes that we wanted to make. So what we're going to do, we're going to modify the lines. And if you're not familiar with most Linux configuration files, anything with the pound symbol, also known as a hash symbol now, hashtag, is that's a comment. So it's not an active line. So what we're going to do, since I have all of this information already here for us, is we're just going to add it. go. It has to be on one line. It can't be two separate lines. So we're going to add this line. And again, this is just doing our password complexities as to what the requirements are for a password on this host. All right. Make that a little bit smaller. And then what we're also going to do is we're going to require that the last 6 passwords have been remembered so that you can't reuse your same password when you go to reset it. All right, so we've set up those configurations. And if I were to go and try and change my password now and I did not meet those requirements, this is a little difficult to see. Let me make that bigger. What you would see is you would get on the command prompt, you would get warnings saying that you're not meeting the requirement. It didn't contain the uppercase letters, didn't contain the alpha requirements, didn't contain the digits or whatever our parameters are that we have set up. So a couple of the other items that we want to look at is we want to make sure that we're logging information as well. So what we're going to do over on the VM side is we're going to make another modification to some additional configuration files. And what we're going to do is you can use any Linux editor of your choice. There's Vim, there's Emacs, there's Nano. I prefer old school VI because that's what I'm most familiar with. So that's what I tend to use. We're adding one other one other feature to our password file that I missed a moment ago. When you're not sure of the name of the file, you can also always do an ls so that you can remember it. All right. Oh, I see what I did. Typo, one too many M's. All right, so what we're going to do is we're going to add in a line here just underneath the default settings. And what this is going to say is that for each user, we're going to log on error. We're going to also deny being able to log back in, attempting to log back in. We're going to be setting an unlock timer. The default is 15 minutes. This is currently configured to an hour. And what we're also setting is we're setting in no magic root. And what that does is that prevents a DDoS attack on the root administrator account so that you can't get the root locked out. That would prevent you from being able to get back into the system at all during any kind of event or incident, or if you're just needing to perform normal maintenance and updates on the system. So now we're going to set some additional parameters for the login, the log files, excuse me. A lot of what we're going to be looking at right now is already commented out, and we're just going to make some minor changes to it. So we also want to make sure that we're logging not only the failed logins, but we also want to be able to see the successful logins on our system. We also want to make sure that the log file, that there is a log file configured as well, which is further down actually. So we're just going to uncomment a few of these lines. And then further towards the bottom, we're also logging sudo and super user and groups and changes. So further towards the bottom here, what we're going to see is there going to be some password aging rules. So how long a password can be used before it needs to be changed, how old the password has to be before it needs to be changed, as well as how many days it will be before you give it a warning. Bear with me just 1 second while I work back up there. You can also set the retry attempts here, but as you can see, in most of this, it will already tell you that the PAM module is actually given priority over these configurations. So if you do set it in this particular file, it'll actually be overwritten by the PAM module that we just installed and configured a moment ago. So what we're going to do is set this to 90 days. Why is that not working? There we go. All right, so we're going to change the minimum password. So you can only change your password once in a 24-hour period is basically what that says. So if you have, let's say in your environment, you have a method of a way that users can get their password reset or unlocked if something happens. Well, what this is saying is if you reset it today, then you're going to have to wait a full 24-hour period before you can change your password again, unless you call the help desk or reach out to your support personnel. So once we've made all those changes, we're going to save that file. We're going to have to do some reboots here shortly after we install some additional items. But the next thing that we're going to move on to is we're going to move on to some of the things that you wouldn't think you'll need on a Unix system. So it's generally a misnomer to think that Linux is not able to be targeted by malware and viruses and things of that nature. It can. It's sometimes more difficult and usually has to be specifically written for that operating system because the primary method that adversaries use is through phishing and embedded links and applications that are generally targeted towards Windows more than Unix. But if you use a particular application that's called Wine on a Unix system, and what that is an application that basically allows you to use Windows-specific applications on your Linux system without having to have it be dual boot or some other type of setup. So if you use Wine, in theory, you could actually be susceptible to those very same Windows-specific viruses. So what we're going to be doing now is we're going to be installing malware, and then we're going to have to update the signatures because with any kind of application that you're installing for the first time, most of the signatures as well as the application in some cases may be out of date, so we're going to have to update it. So let me go back over to the VM. And what we're going to do is we're going to run the sudo command and apt-get. So -y is basically saying yes, because usually you'll be asked the question of if there's a package that's required, do you want to install it, and do you really want to install this program? So this kind of allows you to skip an additional step by putting the Y on the command line. What we're also going to be doing is a lot of the steps that you're going to be seeing me do this evening are going to seem to be kind of onesie-twosie That's purposely done so that I can show you the different parameters and show you how some of those tools function. But in all honesty, you could really install of those all at once in one command. So what we're going to do at the moment is we're installing the antivirus, and then what we're going to be doing is we're going to update the virus signatures and run a brief scan so you can just see what that looks like. Obviously, this is a brand new, fresh system, so there shouldn't be anything on it. So while that's setting up, are there any questions at the moment? So now we're going to get our updates on our antivirus signatures. Okay. One thing to note that is usually a reason some folks shy away from Linux. A lot of configurations and a lot of changes are primarily done in the command line. However, that's not to say that there's not a graphical interface, a GUI interface version of that same tool. For most of them, there is, so that you could do this in a GUI. And I'm going to show you both of the methods, both of those methods for this particular software. Give that just a minute to finish.
Oh yeah, I do have one question.
Okay, go ahead.
Hello?
Yes, go ahead.
Yeah, when you do sudo apt-get upgrade, it usually tends to, take a long time, at least like 50 minutes. So I just want to know, like, what are certain things that you want to do beforehand, before you wait such a long time for, everything to update, that type of stuff.
Well,
what are certain
generally
things you got to
speaking,
do?
now Microsoft has their monthly Update Tuesday. Linux doesn't quite have an Update Tuesday, but it's an ideal practice to check at least once a month to see if there's a new version. So what you could usually do is you could either script something to do that. There's also an unattended command, which will allow the upgrade to happen automatically. I believe the syntax is actually auto upgrade. I don't have that one handy, but I can get that for you.
Oh, okay.
And then you can obviously set up a schedule. And what you can do is, for some of the updates, like within Windows as well, you may see that in the operating system itself, it's waiting for some user input. It's waiting for you to click OK or click Enter or click Next. And what the auto upgrade and the unattended upgrade does is that allows those actions to happen without that human interaction. So it goes ahead and does those actions for you.
Okay. What is it called again? What is it called again?
I believe it's actually auto upgrade. I don't have it handy. I did have it in my notes. Bear with me just one second.
All right.
I'll have to get that one for you.
No biggie, no biggie, no worries. I just,
Okay.
Thank you for the help anyway.
You're welcome.
Mm-hmm.
And just one other item to keep in mind, sometimes my brain forgets it as well, is there is a very, very big difference between upgrade and distribution upgrade. So if we were just going to upgrade the current version, so we're on 16.04 here. So for that, we don't want to go to version 18, at least not right now, not for this particular course. So what we would do is we would do apt-get upgrade, and that keeps it at version 16, but all of the patches that are specific to 16. So if we wanted to go to the next version, we would do distribution upgrade, which is what the distributed upgrade, which is what that particular shorthand is for. You can use full dash upgrade on some Linux or dist dash upgrade, and that's going to take me to whatever the newest operating system level. In this case, I think 18 is what the most recent one is for Ubuntu. There's a couple of other items that are generally considered best practices. Ubuntu doesn't generally have it as much as some other Linux flavors, but there's two additional commands that you may want to be familiar with and use where possible, and that's what's called the auto remove and the auto clean. And what that does is it removes, when you upgrade or do a particular operating system or you do a distribution upgrade, it will be a second kernel if you were to boot up and you're presented with the grub screen to choose which OS you want to, which flavor you want to boot into. There will usually be two. So some other Linux flavors will keep every single version that you upgraded to, and you don't want to have those old versions lying around because we already know they're vulnerable. That's why you had to upgrade. So what the auto remove and the auto clean does is any packages that are old and outdated, it cleans them up, takes them off the system. And if there are any old kernel builds, you want to take those off the system as well. And that's what those two commands do. Now, generally speaking, it's also considered best practice to leave one version besides the one you're actively running. And that is because there is sometimes a chance when you do an upgrade that something that you've been actively using no longer functions, or it may corrupt the file system. So that's your failback, is basically what that is. So now that we've updated the signatures here, what we're going to do is we're going to go ahead and we're going to run a scan. Shouldn't take long because it's only going to do a certain level, a general level scan. We're not telling it to do the entire file system at the moment. So we're going to open the second one. There we go. There's the command prompt. So what we're going to do in this one is we're going to actually open the GUI version, and what the ampersand does is backgrounds this process so that I still have this terminal window available to use and run commands, but it will start the process that I want. So now you see the GUI interface for the virus scanner. Instead of having to put in specific command switches, I'm telling it which particular files and directories you want to have scans, what type of scan you want to do, whether you want to schedule a scan. You can do all of that in the GUI instead of having to do that in the command line. It's always a good idea to at least be fairly familiar with the command line, because it never fails that if you're only used to the GUI or only used to one particular tool, when you really, really need it, that tool will break. So always have a backup. So what we can see here is that it's finished the scan, and you can see it's tested for 6.5 million different known viruses. That's a lot of viruses, and it did it in a pretty quick time, but it was only scanning the one directory because we didn't give it any specific commands. So besides anti-malware, we also want to look at rootkit because, believe it or not, yes, a Unix system can have rootkits. They're usually a little bit more difficult to detect and a little bit more difficult to actually have get on the system, but that doesn't mean that we can't check for them. So this is the interface and the command that you'll see once we run it. So let's go over to our VM, and we're going to go ahead and install that program. So we're installing two different rootkits on Windows. Usually Windows doesn't like to have more than one of the same kind of tool, at least in the sense of antivirus or malware. They have a tendency to basically get into a fight as to who gets permission to look at that specific file indirectly. However, at least for rootkits on Linux, it's absolutely fine to have 2 rootkits installed. So we're going to install both of these at once. And then what we've also got to do is, like I said, with the malware software, the antivirus software, we have to update them. Hope I can spell. It's not like that one. All right, there we go. So we've got that one installing at the moment. And then we're going to go ahead and install the second one. There we go. All right, in that particular instance, I either typoed something or it did not want to install both of those packages at once. So what this pop-up screen here is for is what these rootkits can do is they can send you an email alert letting you know that something was detected. It's best practice to generally be monitoring your logs so that you know what kind of activity has been detected on your system. So we're not going to configure anything at the moment because it's for example. So now what we're going to do is we're going to update that as well. Some commands you can use the -- and then the full keyword for the command. And then some you can just use for like example, the RKHunter -- update. We could have just done -u. Most of your executables will allow 2 different options. So we've got the most recent update here. And then we have to do the other update. All right, so now we're going to go ahead and we're going to run a rootkit detection. Since this is a fresh build, we're not really going to see anything. So as you can see, as it goes through, it's going to be checking for specific types of rootkits, and it's going to tell us, did it find something or did it not find anything? And then at the end, you'll see all of the different things that it's checked, where the log files are located in most cases, and you'll get some additional information from most of the tools that we're going to be running. So Ubuntu does not come with a firewall automatically. Some Linux versions do. Ubuntu does not. Ubuntu is pretty good about being a secure by design out of the box operating system. But if you want some additional protections and some additional layers, then you have to go and install those. So we're going to be installing the firewall, and we're going to be using the graphical interface for this because the IP tables, which is what's used for firewall rules, is in a fairly difficult syntax language, if you will, to use if it's not something you use often. So we're going to cheat and we're going to use the graphical interface. All right. So once that's installed, if you go into your settings, you'll now see a firewall configuration GUI where you can go in there and you can set for whatever specific settings that you want. It is pre-configured with a lot of, it is pre-configured for certain software, as I'm sure there's probably some gamers within the classroom tonight. Let me say that I'm not doing it. All right. So unfortunately, that's going to be just a moment. Bear with me just 1 second.
Hi, Robin. This is Buddy. Were you switching screens?
Hey, buddy. Yes, for just a moment. I'm just pausing the screen for just a moment.
Okay.
Okay. So you could generally go into the GUI interface and you'll have options for a lot of the, there we go. You'll have options for a lot of the different games that are in place. You can put in, there's Steam, a lot of chat programs and things of that nature are pre-configured. It's off by default. So you'd have to go in and turn that on. And at the moment, it's not accepting my password. So we're going to skip that part for just this moment. So now what we're going to be doing is we're going to be setting up an additional layer for our security configurations. So we're going to be preventing what's called IP address spoofing. That might work. So we're going to double check on what the settings are currently set at with our syscontrol. There we go. So what we're looking at is basically we're going to be looking at the IPv4 and the IPv6 accept source routing. The 0 tells us that it is not going to accept that. So if it spoofs an IP, the host is going to ignore that. So another method that we can use to add an additional layer for IP to prevent IP spoofing is in the NC host configuration file. I think my keyboard's running out of batteries. There we go. All right. So right now, the order is hosts and bind. And what we're going to do is we're going to switch that to bind host. So basically, it does DNS. And then we're also going to add a no spoof option. And then, okay, so we've got all of that set up. So now we're going to go back to our slides right quick. And once we get past that, we have some additional tools that we can use to not only validate our configurations and help us is hardened, but in some cases, they will even do that for you. So Bastille will actually run scripts to harden the system for you. There's also SE Linux and AppArmor, which all have to be added to the system. Bastille does not seem to be available for this version of Ubuntu, but we're going to walk through Linus and how that works. So let me switch back over. All right, so what we're going to do is we're going to go ahead and install the Linus software. And this is going to validate all of our configurations. And it's going to tell us in the log files after the fact if anything doesn't pass the configuration checks. It uses the CAS benchmarks. I think some of the configuration checkers use CAS, NIST. Some of them perform PCI DSS level validations to ensure that you are in compliance and that you're meeting all of the minimum requirements for those frameworks. So since we've got that installed, what we're going to do is we're going to step through that. And the C just means to check yes. Oops, it's not showing it. There you go. All right, so we just finished installing it. And that was, again, with the apt-get Linus command. So the apt-get -y Linus. So now we're going to run the actual check. And it can be --check or just the -c option. So now what it's going to be doing, and this is going to take a few minutes for it to walk through. I'm going to just make that larger. You can see that it's running some initialization steps. It's looking at what our different log files are, looking at the kernel build version is that we have. It's doing specific checks on configuration items. These are scorable items on the CIS benchmarks. So we can see that generally red is usually a bad thing, green is good. But because we don't have some of these softwares and we only have what's absolutely needed, it's just a base image that lowers our footprint and makes us, we have less of an attack vector. So we're just going to run through these tests. It's not going to take that long. It's actually fairly quick. So you can see where we have some where it's telling us it's not quite sure if we've met the configurations for that. Our password protection we do have in place, but we didn't reboot yet, so it may not see that. Validating some of the groups and authentications that we have in place, because you want to ensure that you only have users in the sudoers group that actually need it, and you only want to limit who is in the root administration groups as well. So we're going to let this run through all of the different checks.
Hey,
and then at the end,
can you repeat what command you were using for this?
This is actually after you install the Linus program, LYNIS. You're going to just be using the sudo linus -c as in Charlie, or if you want to type out the whole word, it's --check.
All right, thank you.
So we're telling it to run the configuration checks and tell me what is it that I need to look at. So the file permissions, I know I haven't looked at it all, and generally you want to ensure that any of the directories and files on a Linux system are not what's called world readable, and we'll look at a couple of those right after this finishes to kind of get a better understanding.
Okay, yep, thank you.
It checks a lot of different things. There's something like, I think the Linux The Ubuntu specific CIS is like 318 pages. I don't know how many different tests that is. It can do specific framework tests, specific compliance tests. As you can see right here, the compliance test. I didn't tell it to do any of the compliance tests, so it's not. So you can see how many different tests it's performed and what our level of hardening is on a scale of 100. So at the moment, it says we're at a 50. Again, part of that is because we haven't rebooted yet from some of the changes that we made. So as I was mentioning on files, so for the permissions, these are what's called 755, which is the numeric equivalent of what each of these variables stands for. So you have the R, W, and X, and their numeric value is 4, 2, and 1 for executable. So you don't want to have any, especially root, you don't want to have being world writable rather. So 755 is generally the minimum that you want any of the different directories on a system to be. My apologies for that. All right. So back over to the slides. So some other items that you want to have in place is you want to have some file integrity monitoring and HIDS, which is host intrusion detection systems. And some of these tools, both in the security configuration as well as in file integrity, several of them do more than just one thing. They not only check file integrity, they check your configuration settings, they check your application settings, they may perform intrusion detection capabilities, intrusion prevention capabilities. They could even run specific reactions when an alert is fired, so it can kick off a specific script or send out an email. So what we're going to do is we're going to install the program which is called AID. This is the open source version of Tripwire, and it stands for Advanced Intrusion Detection Environment. So again, back over on our VM, we're going to go ahead and install that software. But before we use it, we're actually going to reboot first. So I want to be able to show you the changes that it's going to detect. And right now, because we've made so many changes, we want to reboot first. It's basically just going to be seeing me reboot. So the command that I just did was shutdown space -R space now. So shut down and reboot now, please. So when your drive is encrypted, obviously, as you can see, once we rebooted, every time you reboot, you are going to have to type in the password that you had defined for your encryption, the passphrase that you had defined. So what we're going to do is pause for just a moment. So what I've just done is I've just reverted some of the changes that we made, but that's not going to be detrimental to the rest of what we're about to go over. Because after I made the password changes, it's locking me out. because the password I had used did not meet those complexity rules. So some other Linux builds do come with some of those software out of the box. Some of the pen testing tool builds do generally come with things like, not OSSEC, but they come with things like Linus, Bastille. They'll come with some of the other, some of these different tools so that you can do any of your testing from a different system if you need to. Or in an enterprise environment, you're not going to be installing the software that you need to perform those validations on that physical system. You're generally going to be running those from a different system and running it across the network. So now we're going to install AID. So what it's doing at the moment, post-install, is it's creating files that are on this local system. It's basically creating hashes of those different files so that it has something to compare to. There's some additional steps that we have to do to get this to work as well. We have to initialize it, which is what the next command is doing. And then we have to also update it. So once that finishes, then we're going to run the update. So while that's finishing up, we're going to switch over here to the other presentation right quick. So some of the other items that you can do to ensure that your system is hardened is there are some additional open source vulnerability scanners. There's the Nessus Essential. It used to be known as Nessus Home. Is now once again free from Tenable. I believe it allows you to validate and perform scans to something like 16 IPs. Most of the open and free open source may have some limitations in wanting to use the paid for features, but each of the ones that you have on the screen here, Nessus, OpenBAS, ZenMap, and which is the graphical interface for Nmap, and then Nexpose. All of these give you a level of free vulnerability scanning and will allow you to scan up to X number of hosts. For most of these, it's also not usable in the context of a business environment. So you'd have to get a business license for that if you were needing it in a business environment. So now back over to our VM. It's finishing up. So it takes this particular software a little while to run. So in the meantime, let's look at a couple of different things that we can do while we're waiting on that, some commands to be familiar with. So a couple of the commands that you want to be familiar with for investigating or just even general purpose working on a Linux system is you want to be familiar with what's the PWD, which stands for Present Working Directory. That allows you to know it's similar to the dir command on a Windows system. It allows you to know where is your current location, what directory am I in, so that when you go to make a change on a file, you're editing the correct file if it's a backup directory or something of that nature. There's also the PS command, which will list current processes, and it has a lot of different switches that you can add. So like, for example, PSEF to get some additional information on those processes. You can get a process tree with the specific to show the parent-child relationship of a specific process on that system. The ls command, which is used to list the files in the current directory. Stat, which will display some information for you on the file. The file is used to, in a Windows system, you generally have like the show extension setting that you can use. Well, that's kind of what file does, but it's a command that will tell you if that .pdf is really an executable file. So what I have done is on the other system that you saw just a moment ago, I opened up a browser window. So what we're going to do is we're going to open up a new terminal window, and we're going to run some commands to, there we go, we're going to run some commands to see what that process is doing. So I remember a couple of the questions from the prior class was on hidden files. So there are a couple of ways you can do that in Ubuntu. So for at the moment in the GUI screen, the graphical screen on the right, you don't see any particular hidden files in this directory. So that's the same as the ls-l command on the left. So on that right screen, if we hit Control-H, we now see all of the hidden files that are actually in that directory. On the left, if we use the LA switch, the A means show us everything, and the L stands for long format. You'll now see all of those dot files, which are what hidden files generally are on Linux systems. You now see both of those. And you can turn that on and off in the graphical interface by being in a directory. You can't quite do it from the physical desktop. You have to actually go into a folder view to do that. So another way that you could find view hidden files is you can use what's called the find command. And what we're doing is I'm going to look for files from here that contain a dot in their name, and then I want it to just print them out. So we can see just the single dot because it's using the literal. So let's go ahead and make a test file. So we're just going to make a generic file, and we're going to use the echo command and redirect it to this new text file. So what this command is saying is echo this entire string within the double quotes and then write it to this new file text. So now you can see in both windows, you see the text file showed up here as well as here. I have a bad habit of doing ls-l from years of being on the system. So you can see some general information about the file here. You can see who it was that created it, what time. So this is what the stat command would give you for that particular file. So now we can see a little bit more artifact level information. We can see what file size is, how many blocks it takes up, what the IO number is, how many IO blocks it takes up, the specific inode that it resides in. So everything, as I said at the beginning, on Linux is a file, and each file is basically an inode, so a pointer. So we also see what the user is, what member they are, their GID, UID, access time, modified times, and change times. Birth times aren't used quite so much on the Linux environment. They are used mostly on Windows. So if you were to run a similar command on Windows to get this level of detail, you would be able to see the birth date as well. Excuse me. What we can also do, as some of the tools that the aid is going to be doing for us once it finishes, is it's going to be getting a hash of those files to validate what it is. So what we've done here is I've just ran a command to tell the system, give me the SHA-256 of that file. So I mentioned a moment ago about the file command. So what I'm going to do is I'm going to rename this file to txt.pdf, which you would think would be a PDF file. We know that it's not because we created it. We just watched me create it. But if we were to send that to the file command, it will tell you this is an ASCII text file. So to show a similar comparison, I'm going to cd to the bin directory, and I'm just going to grab cat. And now you can see it tells you exactly what that particular file is, as well as, in this case, it gives you the SHA, the hash in addition. So that's still working. So a couple of other items that you might want to look at is you may need to know information about maybe your IP, for example. So the ifconfig, which stands for, I believe it stands for interface configuration, it's very similar to the ipconfig command on Windows. So it's giving us, in this case, it's a VM, so this would normally be ETH01, so the Ethernet port. And then this is our loopback, so we can get what our IP address is here, our IPv6 internet address, some information that way. So what I was also mentioning, since we have Firefox running in the background, I don't know if you can see it here, but I had started up Firefox. So you can see that it's got a generic default page that it's opened up. So we're going to run through a couple of specific things that you can see. So we're going to run the top command at the moment. And what that does is it's showing the resource usage of processes at the time. So you can see here that it's showing us all of the different information that's being used by these particular processes, giving us the process ID number, who it was that started it, some virtual information, how much CPU it's using, how much memory. We use the Z key. We can change and use color coding. Sometimes it's better, you can configure these colors to be different colors. We can use the M key to look at different information. We can use the memory in a gauge in that manner, or we can just do it numerically. We can also do P, Shift P, which puts it in, sorts it by highest CPU usage. So we can get some small information on Firefox. We can see that there's actually, it looks like there's a couple of different things, but that's because this one page is actually doing a lot of different connections. So we're going to look at, if we wanted to get, let's see, AOX is always my fallback. If we wanted to get some additional information, like maybe we wanted to see a tree of the process, it's difficult to see. It's shown a little bit. You can see the Firefox process started here. We have an edit open, and then you can see from that Firefox, there's several different things in the background that are actually running. So if we wanted to see those network connections, we could use the netstat command. And we're going to add a couple of switches here. So the A stands for all. The T is we're specifically looking for TCP protocol, not UDP protocol. We could leave the T off and it will go all of them. We're also telling it the N switch, which is just show us the numeric address. Don't do a DNS lookup on those. And then the minus, the P option tells us what program is it that's running it. So if we took off the N, you would see where it has an actual DNS name for the address and the port instead of an IP address and the port, as well as what program started it. Now back to the top, one of the switches I forgot to show you is you can add the C command, which gives you the full path of what it was that was running. So let's go back over to our other window right quick and see if that's finished. It has. All right. So we're going to close out of that. And then, so now we've got to update the comp file. That one's not going to be as long because it's not, what the command, the reason that the last command took so long is it was running and doing a hash on every file on the file system, basically. So now we're going to also copy the files into their proper folders. Bear with me just a second, it errored out. No. Much better. All right, so now that we've copied those files to initialize it, now what we're going to do is we're going to tell it to do a check. But what we're going to do first is, I know we've made the one file, but what we're going to do is we're going to go into the temp directory, where there may be some stuff hanging out because of doing the update that we had done, and then the system has a tendency to write. The temp is a temporary working space, basically. It usually is, whatever you write into this space is deleted once you reboot. So what we're going to do is we're going to make a directory called test1, and then we'll go cd in test1 and make a new directory. And a file. All right, so what we've done, I've missed a quote. So now we have two directories and a file that we just created. So we're going to go back to our home directory. There's a couple of different ways you could do that. You could do CD, or you could do cd tilde. Both will take you back to your home directory as the user that you are. So now we're going to run a check, and it's going to spit out a whole lot of information because we just installed the aid program. So what it's going to do is it's going to be running a comparison against all of the files on the file system to see if there's been any changes to those files. Now, one thing that could potentially cause you to see false positives on that would be if you just recently updated your system. You may have files trigger as being changed because the system changes them. And then some files are constantly written to, like log files, for example. So they're going to be constantly changing. The file hash is going to be constantly changing on those. Most of your file integrity allows you to be able to exception and ignore those specific things so that you don't end up having a whole bunch of alerts firing off for something that you really didn't want, something that you know is going to be changing constantly. So while that's working, what we're going to do is, let's say we want to get some system level information. You know, what is the operating system version that we're running, some things of that nature. So you can use the uname command. There's a couple of different, pretty much every command that you use on Unix has some switches that you can use with it to give you some additional information. So just uname tells me what this is. But if I use uname -a, which stands for all, now we get a lot more information. We can see what, you can see that it's a Linux system. That's the operating system type. You can see what the host name is. You can see what version we're on. And then the patch level version. You can see time and date stamp, whether it's 32 or 64-bit. Another way you can see that similar information is to cat the OS release file. And it's basically, the OS release file is a different way of listing the same information that we just got from that uname command. So another command to be very, very familiar with is, in most Windows applications, you're used to seeing some type of a help option or help feature. Linux does kind of have that, but it's not called help. It's called man, which is the actual online reference manual, basically. So if there's any command that we want to know how to run or what the available switches are, we can simply type in man and then the name of that particular item. And you'll get a big write-up as to what is the name of that particular process, what information does it give us, what are the different switches that we can use. Sometimes it'll give you examples in both the -- and the singular dash notation. So you can, it's a matter of preference if you want to use the full word or a shortcut. So if you scroll through it, it'll tell you exactly what each of those different switches does. And then usually towards the bottom of the man entry, you will sometimes see specific examples provided to show you how to properly use that switch. And then it may also tell you some additional tools or programs to be familiar with to get information on that item as well. Couple of tools that I use all the time. Let's say we're going to become root for the moment using the sudo command. And we're going to run who am I, so we know I'm root. but I'm actually test user. So I'm not sure if you caught that, but the who am I command tells me what is the account that I am currently using, but the who command tells me who it is that I logged in as. You can also use a similar one as ID, and that gives you a lot more detailed information. It tells you the specific UIDs, the numbers, the numerics for your account, what the GID is for it, what groups, some of the group memberships you are. Sometimes groups is an easier way to see that. As you can see, it's the same information. It's just that ID includes the numbers, the numerical value of those different groups. Now let's go back and see if that's finished yet. Still working. There we go. All right. So now it just finished, and you can see it's telling us, scroll up here. We're going to have to back up quite a ways because we did install the program itself. So what you can see here, or hopefully you can see, is it's telling us what all of the files that changed, and then whether they're a file, a directory. I'm going to get it up, scroll back up. There we go. Cool. All right, I think that was pretty smaller. All right. So what we can see here is we can see that it's performing tests. It looked at 234,000 different files on the system, and it's discovered that 565 of them have changed. 6 have been deleted, rather 565 have been added, 6 deleted, and then 60 changed. Now the files that we made in the temp directory, I forgot to delete, or it would show those as well. But what this is showing you is some additional information. The F obviously stands for file, and the D for directory. A lot of these look like garbage almost, because that's the encrypted file system that it was looking at. So what we're going to do is scroll down to some more readable ones. So you can see that Firefox, when it started, wrote to a bunch of files. And then let's scroll up and see where it has. You can see the run logs that changed, some root logs that changed, a whole bunch of stuff in the directory changed. We also wrote a couple files. So do you see how it gives you that, all of the information about what files changed? Gives you all the hash, what was the prior time that it had been modified and written to, and what's the current time that it's been modified and written to. So there's a couple of different ways if you wanted to recover files on Linux. It's not impossible. There's a few different ways forensically you can get artifacts from not only Linux but also from Windows systems. You can use specific tools. You can take an image of that system, a forensics image of it, so that you can recover those files. There's a program called Test Disk on Linux, but it's actually PhotoRec. It's the same program, can be used on both Windows and Linux to recover files. You can use the LSOF command. I'm not going to go into that too much, but I think I still have Firefox open. We're going to use the LSOF-I, which means we're looking for established connections. It's similar in nature to the netstat command, but what I said at the beginning was that everything on Unix is a file, what LSOF stands for is basically list of open files, because everything is a file. So let me switch back to the presentation and go. Not going to go through this at the moment. I'm just going to cover it briefly because I just saw the time. So basically what I have done is you can actually use LSOF to recover a file if and only if the process that created that file has not ended. So what this is showing you, with a little difficulty to explain, is where we had an open browser, a second browser window open, like I showed on the VM. I could create a file on that, in that process window, and then delete the file, which is what the screenshot is showing here. And then you would see that the file no longer exists. But since I left that process open, it's still in memory and still has an inode pointer. So what this section down here is doing is I'm using the LSOF command once I've determined where that file was to get the information to know what inode pointer it is, and then I'm using that to recreate the file that I just deleted. That only works if the process has not been closed or crashed. So obviously in a business environment, some additional things to consider are if it's an SSH server or an NTP server, DNS web server, there are going to be more security configuration changes on those types of server that you would not necessarily see on a desktop. So with that, are there any questions?
Yes, I did
And then
have
some resources.
one student asking about the log files, and she was interested if you could just explain when you're looking at the auth.log file and how you can use that to understand the accounts that are signing into the system.
Okay, because I just changed that one, we may not have, bear with me just 1 second. So one of the ways that you can do that is without looking at the actual log file itself, but I'll show that as well, is in the VM, you can use the last command, and that allows you to see some of that information from those log files without actually having to go through those log files. And that's going to tell you who logged in, what type of connection they have. In this case, it was a terminal. And then what time they logged in, how long they were logged in, if they're still logged in. Gives you a lot of information. I don't remember how long. I think that will store information until the file overwrites. So it could conceivably be a fairly large file. Now, as I was saying earlier, auth.log is what it is on Ubuntu, but it may be a secure log on other systems. You do usually have to be root or use the sudo command to see that log, but it's basically going to give you the same information that I showed with the last command, but in a slightly more readable format. So give me just a minute to find. So we can get additional information from this log as well. For example, we can see where I was powering it down earlier to make some changes. Let's get to the end. So you can see in this particular log, because I didn't set up the specific sudo logs since I reset it, you can see that I have sudo to root, and should also see the commands that I ran just now so that I can view this log. You will see further up, it's going to take a minute to find them, but you will also see where I logged in as well. Does that answer the question? There's a lot of very good logs available for you on the system. It depends on the different flavor, whether it's auth or secure, or message versus syslog, and how the
Yes.
administrator configured it.
Yes, it did.
And then in the slides, which will be uploaded to the recorded session, there is some links that I've provided to some additional resources. And for all of the pages where I discussed the configuration tools and file integrity and vulnerability scanners, there are links to either how-tos, how to install those on a Ubuntu system, or links to download those with Ubuntu.